Hello, and thank you for attending my presentation. I'm Donnie Locklear, supervisor of the City of Raleigh radio shop. This presentation focuses on how sensitivity analysis supports effective capital budgeting for Raleigh's public safety communications concerning radio communication upgrades. Operationally, our radio shop supports the Raleigh City Police Department, Fire Department, and Emergency Communication Center by maintaining mobile radios, handhelds, radar, LiDAR certification, recertification, and preventative maintenance on all transmitter repeater sites. We manage preventative maintenance schedules for the team, training, battery, battery recycling, and surplus reissue, all of which impact annual budget planning. Part of this process supports environmental responsibility and data security for the City of Raleigh. Financially, this approach entails an in-depth financial analysis that moves beyond initial purchase price to consider long-term budgetary impact, such as radio upgrades, evaluating life cycle costs, and replacement schedules, to include new systems' expected life versus old systems' remaining utility. Vendor pricing variances, comparing different vendors, and projected maintenance savings, reduction of repair cost and downtime. Sensitivity analysis helps us understand how changes in these inputs affect total project cost, net present value, and operational readiness. Slide 2. Goal and function of financial management. Financial management ensures taxpayer dollars are allocated efficiently within our communications budget. Operational decisions include scheduling preventative maintenance, replacing outdated radios, coordinating training, and ensuring ECC uptime. Financially, we must balance short-term maintenance costs with long-term capital planning. References Peranovic 2025. Sensitivity analysis helps you figure out which things like sales prices or exchange rates make the biggest difference. Functions including forecasting life cycle replacement costs, evaluating vendor proposals, planning for cost variability, including labor, equipment, tower maintenance, and ensuring funding for critical infrastructure. Sensitivity analysis supports these financial functions by modeling cost changes and analyzing their impact on long-term capital outcomes. Slide 3. What is sensitivity analysis? Evaluates how changes in key variables affect capital decisions. It enables us how to test how uncertainties such as equipment costs, increases, or supply chain delays affect financial viability of communication upgrades. Referencing Regulashek 2025, it allows decision makers to assess robustness of projects' profitability by systematically altering key assumptions and observing the resultant impact on metrics like NPV or net present value, the IRR, internet rate of return, and PVP, payback period. Operational impacts include downtime risk, service reliability, and interoperability with police, fire, and ECC systems. Financial impacts include cost overruns, accelerated depreciation, and higher than expected maintenance expenses. By modeling best case, worst case, and expected scenarios, we better prepare for fluctuations in vendor pricing, life cycle assumptions of equipment, repair frequency, and training needs. Slide 4. Quantitative steps. Establishing baseline projections. Quantitative is Quantitatively, sensitivity analysis begins with establishing baseline costs for radios, repeaters, ECC consoles, tower maintenance, and labor. We identify key cost drivers, for example, radio unit pricing, contractor labor hours, projected failure rates, and consumables such as batteries and device accessories. Financially, we model how changes in these variables affect NPV, IR, payback period, and annual operating cost. Operationally, increased failure rates or maintenance needs can shift upgrade priorities and affect staffing, contractor workload, and overtime budgets. These quantitative tests allow us to identify the financial breakpoints where an upgrade becomes cost effective or risky. Slide 5. Qualitative steps. Qualitative analysis captures operational factors not easily reflected in financial models. Operational considerations include radio reliability during emergencies, interoperability with regional systems, FCC compliance, and vendor service quality. Financially, poor vendor reliability can lead to unexpected repair costs, delays in deployment, and costly system redesigns. We also consider personal readiness, ensuring technicians, contractors, and ECC staff can operate and support new technologies. Environmental factors such as battery recycling programs and surplus resale also influence qualitative risk evaluation by reducing long-term disposal and procurement costs. Slide 6. Next slide. Internal risk assessment methods. Internal risk methods rely on department data, preventive maintenance logs, equipment failure trends, departmental uptime metrics, contractor hours, and historical spending variances. References Peruma 2025. Regardless of where the risks originate, it's essential to be aware of and manage them as you plan and execute your strategies and tactics. Financially, this data allows us to model realistic maintenance costs, replace cycles, and operational savings from preventative maintenance. We also use scenario planning to evaluate how changes in internal resources, including staffing levels, contractor capacity, and equipment condition, can affect project costs and timing. Operationally, higher than expected failure rates are at transmitter sites or repeater sites may indicate need for accelerated replacement, which must be reflected in capital budget projections. Next slide, 7. External risk assessment methods. External risk methods consider vendor pricing trends, inflation, supply chain issues, regulatory changes, and technology advancements. Financially, this affects discount rates, cost estimates, and projected lifecycle expenses. For example, supply chain disruptions may increase lead times for radios or repeater components, raising total project cost and delaying operational improvements. Benchmarking against peer cities will provide added financial data points to justify upgrades or negotiating price. Operationally, external standards such as Association of Public Safety Communications, the APCO, Federal Communications Commission, FCC, and regional mutual aid requirements with local cities and townships will drive system interoperability needs and influence long-term capital planning. And concludes my presentation on sensitivity analysis as a tool for capital budgeting for radio communication upgrades. Thank you.